Hi everybody. In this short video I'd like to talk about how we can use our graphing calculator to find the linear regression equation, or the best fit line that goes through a set of data. So we know if we have just 2 points, 2 ordered pairs, I can find the equation of the line that goes through those points. But what if I have a whole bunch of points that aren't necessarily all exactly on a line? And so there's some statistical formulas that are built into graphing calculators that allow you to find the line that best fits that data. So here's an example taken from Bittinger, Ellenbogen, and Johnson's Intermediate Algebra Graphs and Models textbook. It says the life expectancy of males in the United States is given in this table. In 1960 the life expectancy was 66.6 years, and a decade later it had gone up a little bit, and you see it's just increased somewhat. and the question asks us to use the linear regression capabilities of our calculator to find a linear function that can be used to predict the life expectancy, capital M, of a man as a function of the year. And we'll let x be the number of years since 1990. Since 1900. So in 1960 would be 60 years from that, right? So this would be my x value, and so on, 70 and 80 and 90 and so on. So, and these would be my corresponding y values. So let's get my calculator out here, and let's see if we can enter this data, and we'll be able to even plot it and see what it looks like using our calculator. So let me go ahead and clear this out. And whenever I'm entering any sort of data, I want to think statistics. So I'm going to go over here on my calculator and find the statistics button, and I want to edit the statistical register. And you see I have some values in here. I'm going to clear those out. I arrowed up onto the name of the title of the list there, hit clear and enter. And I'll go over here to list 1. I'm going to hit clear and enter, so it's going to clear out anything that's in there. And then I'm going to go ahead and put my x values in list 1. So I'd want 60, enter, 70, enter, 80, 90. So 2000 would be 100 years after 1900, and 103 would be the year 2003. Okay, and then I'll arrow over into list 2, and I'll put the corresponding y values there. So it was 66.6 was the life expectancy for males in 1960, and then it went up to 67.1 10 years later. Then it was up to 70, then 71.8, and 74.4, and 74.8. Okay, so make sure you have the same number of x's and y's so you didn't make a mistake in transcribing it, otherwise you'll get an error on the calculator. And then what I'd like to do is be able to plot that data so I can see, well, is it somewhat linear at least? So I'm going to come up here in my graphing things, and you can see that there's a special function here, stat plot. So I'm going to hit second, stat plot, and we only have one plot that we're trying to do right now, so I'll hit enter. So this is plot 1. I'm going to turn it on, and then I want the type to be a scatter plot, and that's this one. It just plots the points. And my x's are stored in list 1. That's typically the default, and my y's are stored in list 2. You could change that if you wanted to. And the mark, if you have just a small number of points, use this big mark right there. Okay, so now all I need to do is graph that. That's actually going to plot those. Let me go to the y equals, make sure I don't have any other equation in there. And if I hit the graph right now, you notice I'm not going to get anything, because the point I plotted was 60 for the x coordinate and 66.6. So that's of course way over here. So I need to change my window as well. And the way I'm going to do that, there's a special zoom feature. If I go to the zoom button and arrow down here a ways, I think it's zoom number 9, is zoom stat. And what that does is that looks at the data you're trying to plot and will automatically create a window to contain those. And so you can see that those there's definitely an upward trend. They're not exactly on a line. If you hit the trace button, you can actually see your point. So here's 60, 66.6, and so in 1970 it was 67.1, and you can see how they relate to one another, how they are the graph is there. Okay, so what I'd like to do now is find the line that best fits that data. So I'm going to go back to the statistics button, and I'm going to arrow where it says calculate now. I want to calculate, and regression is the mathematical term for finding equations. And if you were, if the data looked more like a parabola, then you'd use the quadratic regression, or like a cubic equation looks. But I want number 4 here, the linear regression, because it looks like it's fairly linear. So let's hit number 4. And then the default for the linear regression is for list 1 and list 2. You'd have to put a different thing in here if you wanted that. So I hit enter there, and it gives me the equation y equals ax plus b. So it's saying that this right here is the equation that best fits it, and these other variables r squared and r, they give you an idea of how good a fit, how close to being perfectly linear it is, and if it was exactly 1, that would be perfectly linear, and you can see it's pretty close to 1. So this data is in fact pretty linear. Now what I'd like to do, I can either write those things down, y equals about 0.205x. Okay, I could just write that down, y equals 0.205x, and then I need the y value, or the b is 53.597 if I rounded that off, plus 53.597. And then I want to, so that's pretty close to what it is. Let's also, if I want, what I really want to do is go to my graph and plug those in. So I can, after writing them down, I could plug them in, or this is the age of computers, it's actually stored in my calculator. So what I could do is I could go over to my variables button right here once I'm in the y equals. Okay, so I'm going to go to y equals first, put my cursor where I want the equation to be. Then under the variables button, you'll see down here number 5 are some statistic variables. And so here's all sorts of different variables that we use in statistics. But if you arrow over here where it says EQ for equation, the very first one there is regression equation. So I can just hit enter, and fast as lightning, it'll put all those details. Right here's the 0.205 and a whole bunch of other digits times x plus the 53.596. And so then I can graph that with my calculator in relation to the points, and you see that does pretty well describe that set of data. Okay, so in terms of m, if I were to rewrite this, it said use the linear regression to find a linear function that can be used to predict the life expectancy m. So this would be m, the male life expectancy is about 205x plus 53.597. Okay, so for part B here it says, so now I have a thing. So if this was to continue in 2009, the life expectancy 2009, that corresponds to an x value of 109 years since where we had our 0 point, which was 1900. So m of 109 would be 0.205 times 109 plus the 53.597. Okay, and we can again do that on our calculator. I can actually show that even on my calculator here. Notice my window. Let's go to my window here. My window actually only goes out to 107, so that's like 2007. So what I could do is just extend that a little bit. Let's take it out to 120, should we? And then I probably need my y's to go up a little bit. Let's put those up to 90. Okay, and while I'm at it here, well, I guess I can leave the y scale. That's close enough. All right. So now you could go ahead and calculate, and you can plug in whatever value you want up to at least the 120 here. So if I plug in 109, that'd be 109 years from our start. We see that corresponds to about 75.9. We'll just round it to the nearest tenth. About 75.9 years. Okay, so I can make a copy of that. There we go. So roughly that's going to end up being about 75.9 years there. All right. So thank you for joining me.